Hello and welcome to this session of CCNP Encor series. In this session, I will discuss one of the most critical aspect of wireless LAN design, client density. Whether you are designing a network for a small office or a large stadium, understanding how to handle client density is key to ensuring seamless wireless experience. So what is client density? Client density refers to the number of wireless devices connected to a single access point in an area. For example, imagine a conference room with only one laptop connected to it. One laptop connected to an access point. That laptop can use full available bandwidth. Now imagine 100 people join the network. Like each device will get a fraction of that bandwidth, and the overall performance drop significantly. The more clients that connect to the EP, the less airtime each client will get. Like if you see now, if I keep on adding more users, the bandwidth and the performance per user will go down. So this results in slower speed, higher latency, and poor user experience. This creates a unique challenge for wireless LAN design. In high density scenarios, poor design can make your network unusable. That's why understanding and planning for client density is very, very crucial. So let's look at some of the design consideration for high client density or to support high client density. The first one is RF coverage. A good wireless design should provide RF coverage everywhere it is needed. It should increase the AP density, like add more APs, deploy more APs. But adding more APs will add more interference. So proper channeling is crucial. So you can use more APs with lower power settings or use smaller cell size with lower power levels to minimize interference. You can also reduce AP transmit power, which will prevent clients from connecting to distant APs. You can use 5 gigahertz over 2.4 gigahertz. Because 2.4 gigahertz will give you long range but more interference, and only 3 non-overlapping channels. If you see here, if you see on the left, there are only 3 non-overlapping channel available. That is 1, 6 and 7. Only 3 non-overlapping channel available to minimize the interference. The risk of co-channel interference on 2.4 gigahertz very high because we have if you have many APs and clients. So the safe option is to go for 5 gigahertz, which has more non-overlapping channels, high speed, and it is better for high density. So 5 gigahertz is usually the better choice for high density network because you have, if you see here, more channels. Like when you're running 20 megahertz, it will give you like 24 non-overlapping channels. Another design recommendation is if you see here, there are different channel you can operate, range you can operate in. Like for example, bandwidth 20 megahertz, this will give you more channels, and if you increase that bandwidth range then to 40 megahertz you will guess sorry, with 40 megahertz you have 12, and again with 80 megahertz you will have 1 2 3 4 5 6, and then again if you increase it to 160 you will have only 2 non-overlapping channels. So it's better to use 20 megahertz for higher density. Another design consideration is to use Wi-Fi 6. If you are looking for higher efficiency in dense environment, 6 megahertz is your answer. Like it offers more capacity, less interference, and ideal for high density areas. Another design consideration is distribute your clients evenly across APs to enable network optimization. And another one is to limit the number of clients per AP. Like one way to manage high client density is to limit the number of clients per AP. You can also limit the number of clients served by the AP by selecting proper antenna, like an antenna that has more constrained coverage pattern where the clients are located. For example, directional antenna, which focuses coverage where users are located, for example, in auditorium and all. And then there is a sector antenna, which reduces interference and provides distributes client in a better way. So a well-designed antenna pattern can control how clients associate with AP, balancing the load efficiently. And the last one is you have to consider the client device capabilities. Like you have to consider the type of device connecting to your wireless network, for example, smartphones, laptops, IoT devices, and you have to design based on their capabilities. That's it for this session. I hope this was informative for you. In my next session, I will discuss design principles of SD-WAN.